Rajiv and I were talking about all the customer conversations we have with people building generative AI stuff, from startups to big companies. And everybody asks how they know if their stuff is working. And it's a conversation that we've been having in various forms for the last year and a half or more if you've been working in generative AI. We rely a lot on vibes, and we know we need evals and observability, and we don't always know how to do it. And maybe I'm just speaking for myself. But so we invited a bunch of people to show us pieces of the observability and evals landscape, which is evolving very fast. So we're going to get a little snapshot tonight, and then hopefully we'll have a lot more to talk about if there's any pizza left afterwards. Let's get started, and I would love for you to just introduce yourself and what company you're from and jump right into your demo.
Sure, yeah. Thanks, Quinn. Hey everyone, my name is Tim Sweeney, and I'm an engineer at Weights and Biases. Some folks in the audience might know Weights and Biases as a toolkit for developing and training machine learning models. Today we're here to talk about Weave, which is a product that we develop specifically for developing and evaluating LLM applications. Great, let's go ahead and dive in. So essentially what we noticed in the market is that developing LLM applications is more challenging than different types of software development. Git workflows work, but not all the time. Test-driven development is useful, but hard to do with these stochastic models. Turning vibe checks into actual metrics can be challenging. We have a toolkit called Weave that we hope you try to help better improve your processes as well as your evaluations. So let's go ahead and dive in. Easy to prototype, hard to engineer. I'm going to say a lot and you're going to see 6 demos. So the call to action, pip install Weave and call weave.init at the top of your applications. This will auto patch a number of common libraries and automatically start tracking all of the important information. Then you can up level from there and continue to annotate your code, but this is how to get started, and 80% of the value is right here. I'm just gonna quickly mention that Weave basically is composed of 3 main concepts. We have traces, which help you debug and analyze the actual execution of your LLM application. Think calls to OpenAI, calls to vector data stores, pre-processing and post-processing outputs, etc. We have models and data sets which allow you to store configuration, repeat experiments, and otherwise capture production traffic and turn those into evaluation data sets. And then we have evaluations, which I think the best way to say is we transform vibe checks into repeatable, comparable tests. So with that, I'm gonna jump into a demo and let's go ahead and dive in. So here I have a Streamlit app running. If you're not familiar with Streamlit, it's just a quick way to spin up a little application. And I have an Apple customer support bot. So let's imagine we're building a little support bot. And here I want to say, sell me an iPhone. So there's no Weave hooked up to this right now. We get a nice response back from GBT. And a lot of the code as I scroll through will look familiar. Now, if I just do the one call to action that I asked everyone here to do, cursor thinks I'm going to put it there, but I'm going to put it there. I just click save, jump back over here and say thank you. What we're going to see is in our terminal output on the right-hand side here, we're going to see that, I guess it's over here, is that we get a link to a new trace. So just by adding that one line of code, we are now tracking this OpenAI call. On the right-hand side, we can see all of the inputs and outputs. You can even see the system prompt that I've pre-configured. You can take a look at the content as well as the entire output payload just from one line of code. We can also see metrics like how many tokens, what model was used, what the cost was. We can see the environment it was run on, who ran it, as well as a few other pieces of metadata. But that's not all. Let's keep going here. The next thing you might want to do, so calling out to LLMs is one great technique, but oftentimes your application is composed of many different functions. So here we introduce a decorator. So at weave.op is the magic decorator. You can sprinkle this throughout your entire application. What that'll do is track the overall topology and trace of your application, allowing you to roll up prices, token counts, and better understand what's going on with your system. So I simply click save, and I'll jump back to our demo, to our Streamlit app, and say, okay, what about an Android? Okay, we are demo typing, so forgive me for any misspellings. Jumping back to the application over here, I can see that I now have a trace called handle user input. And those of you who are looking closely may have noticed that's the name of the function that I just decorated, and we've automatically tracked the underlying OpenAI call as well. So here I can see that we have the appropriate inputs and outputs. I've also automatically tracked the code. For those of you who are actively iterating and developing, you know that code tracking is really difficult between commits. You're making experiments, you're changing prompts, etc. This is all tracked right here. Just to emphasize that point, I'm going to change the system prompt a little bit. Let's just say important with some exclamation marks. And then I'll show you one more feature before oh wow, we are cranking on time. So let's just do one last little thing here, and then I'm gonna shortcut a little bit of this. So I'm also gonna throw in, sorry about that, weave.attributes. So this is one more feature I'll showcase here. Oftentimes you want to track calls in production environments, demo environments, CI/CD, etc. Sometimes you want to associate calls with certain users so that you can later retrieve them back and build your data sets. With this simple decorator, everything called underneath will automatically be tracked. So let me go back one more time and say, sell me that Android. Okay. And then once again, jumping back to the traces here, we can see that this env is now set to demo here. And we can see, I can option click that, go ahead and filter down to all of my env demos. Maybe I want to export that to a number of different file formats. Maybe I want to consume it using Python or curl that out, and again, build my downstream data sets. I guess the one last thing that might be interesting to show here is that in our operations, handle user input, notice that I changed that one character earlier. It should highlight this diff. If I did this correctly. I'll do one more refresh, but if it doesn't, then that's the demo gods for you. Okay, great. We highlighted the diff, and we can see somewhere in here I've added that exclamation mark to the important section. So that's a way of tracking those features. I see we're on time. I have one more thing I can show.
Show us one more.
Okay, cool. So the last thing that you might want to do is actually represent this as an evaluation. That's the theme of today's conversation. So here I have a script called evaluate.py. Evaluate.py, we construct an evaluation, but the important thing to call out here is I've made a bunch of sort of adversarial examples where I've asked it to, so let me turn on word wrap, sorry about that. I've made a bunch of adversarial examples. Sell me a Windows machine, sell me an Android device, like trying to get this Apple thing to do something that it shouldn't do. And then I've defined a scorer, which yet uses another LLM to define a guardrail to say, please never ever promote an alternative product or an alternative business. Because of the stochastic nature of the system, we want to enforce that guardrail. So I will go ahead and run that, but I can also just jump to one that I ran earlier today, just in interest of time. I think this is make evals. I made it nice and easy. So that's going to run an eval script. I will open up this result. I'm going to run this on two different cases. I'm going to run this on GPT 3.5 as well as GPT 4, and I'm going to compare the results. And here we can see that did I click the right ones? Scoring inconsistency detected. I did not click the right ones. Thanks, Weave. Great. Let's go ahead and.
That was actually really impressive that you told you didn't have quite the right comparison.
Cool. Thank you for noticing that. So here on the red, we see we have GPT 4.0, and the blue, we have GPT 3.5. We can see that it scored 100% on the score, and the other one did not, with a little bit more latency and tokens. I can then zoom in, for example, to a specific case where GPT-4 outperformed GPT 3.5 and further analyze these specific results. Again, all from a few lines of code and a few decorators. That's it for me. Thanks for the time.
No, this is awesome. I think one of the useful things about something like tonight, for me at least, is getting a little bit of context and trying to understand how the pieces fit together. I think of weights and biases as an indispensable tool when training a model. How did that history of the company inform the development of this inference time tooling?
Certainly, yeah, it's a great distinction. The primary value prop for our core product is really around training, where the use case is around high volume data sets, expensive GPUs, long training times, etc., and being a system of record that delivers you insights for your iteration. The same theories apply to LLM applications, where we just take a different use case. It's higher volume, it's more stochastic, it's more qualitative in many cases, but you still need a system of record that allows you to derive insights from your experimentations and continue to iterate. So it's a similar mental model applied to the next step in that pipeline.
Is there some graphic that's as dopamine friendly as the loss curve graphic in the training dashboard?
Oof, we can make one. We can make one together.
Thank you so much.
Cool. Thank you so much for your time.
Thank you, everyone. It's great to be here. My name is Tom. I'm one of the co-founders of Canonical AI. We're building Mixpanel for voice AI applications. In short, what we're building is something that maps out all the caller journeys for a voice AI agent, and then gives the developer the ability to drill into different call paths and figure out what's going wrong in those call paths and figure out how to improve their voice AI agent. A little bit on the problem that we're trying to solve is that voice AI agents don't always achieve their goal. And developers, the way they're figuring out what's going on with their voice AI agent is they're listening to calls. They're listening to recordings, and there's only so many you can do a day. And I talk to some voice AI developers that say, oh yeah, I listen to 1 or 2 a week. And I'm like, how many are you processing? 5,000 a day. It's hard to listen to enough calls to figure out what's going on in them and how to improve it. And so the solution we're building is something that maps out all the caller journeys and gives the voice AI developer like the big picture of here's how my voice AI agent is performing. A little bit on how our analysis pipeline works, so you can really, at least as a technical person, like I want to know what's going on before I can really understand what it does. Developers make an asynchronous call to upload their call recording to our API. We take a number of the transcriptions and the system prompt or the system prompt to figure out the typical stages that a voice AI call goes through. Then once we have those typical stages, we can map every conversation turn to one of those stages. So what we have after processing one transcript is something that looks like greeting, recording consent, farewell. And then we do that for every single call that you have. And once we do it for every single call you have, you get a map of all your different calls. And in addition, we also do a bunch of audio metrics like latency and interruptions and other things that are important to voice AI developers. So this is an example. It doesn't make a really nice real-time demo. We didn't build it. Our last product we were building was a semantic cache where we have to be very focused on making it run really fast. This one's async. It feels much easier. And it also doesn't make for a really fun demo because it's not intended to be super fast. So let's pretend that you heard me make 6 calls to a voice AI agent that I developed for a call dealership. And what you're seeing here is the map of what happened in those 6 calls. But they start with greeting. The next step is you determine the call, the AI agent determines the call purpose. Then half the calls go into scheduling an appointment and the other half go into scheduling a callback from a technician. And you can see at certain stages that something drops off. Some of the calls dropped off, and that's the sort of thing that as a voice AI developer, you want to see what's happening in that call, what's going on. So you want to drill deeper, and that's where I'm going to pop over to the application. And what I'm showing here is at the top, you can pick different call paths. And then once you pick a call path, you can see all the calls in that call path and dig in and see things like a summary of the call, what happened, audio metrics like late, and then things like the actual transcript. I should probably raise that a little higher.
So who's the target user of this? Who are you building this for?
We're building this for people that are building voice AI agents that do things, and they're people that are selling something like a voice AI for a call dealership to answer the phone, or a plumbing company to answer after all hours calls.
And who looks at the dashboard? What's the role of the person who actually has to engage at this level?
It's interesting because it seems like every company is a little different. Sometimes it's a technical person that's like writing the code around and the prompt, but sometimes surprisingly, maybe I shouldn't say surprisingly, but it's people in other business functions that are, it's like every company has somebody that's the prompt artist, the conversation artist, and it seems like we're working with that. Is that something that you've seen from your experience working in voice AI?
Absolutely. There's just all this stuff is so new. There are so many different people who need to touch this stuff for it to be successful. And that was why I was asking, because I was curious like who not just your target customer you sell to, although that's obviously very important, but your target user of this kind of analysis.
I'm not sure how I'm doing on time, and I always think shorter is better with me, so I'm going to skip to my last slide now.
Show us one more thing.
Oh, one more thing. We're still pretty early, so I don't know. Another thing you can do is you can filter by the stage of the call. So if you want to see, like, my calls, they're all falling off at the confirm appointment detail stage. You can see all your calls at that stage and the transcript at that stage to see. It's always people asking, are you a real person? And then it falls off, or whatever's going on.
That's actually really interesting insight, like how we build these new AI tools so that they become part of people's lives with kind of a natural glide path of behavior adoption, I think is a totally open-ended thing. Tell us how you came to this product idea.
So I first met Quinn through building our last product. We were building a semantic cache to reduce the latency and costs of LLM applications. We were targeting voice applications first because latency is so important for the user experience. And it's a really interesting idea with semantic cache. So I think it's appealing to developers, and it's definitely, latency is a big enough problem that you can get voice developers to talk to you, but nobody was integrating, or they weren't integrating fast enough. Some people were integrating, but just wasn't going fast enough. And then we went back to all these friends we've made in the voice AI space and said, like, what's the problem that's stopping you from integrating the cache? And they're like, I just need to make the thing work. And there's this 5% of the time it's not working, and I can't bring on this customer until I solve that 5%. And I'm listening to audio calls. It's not working. I need a way to see what's going on in my calls.
Make it work, make it fast, make it good in some order, but make it work first, probably. Yeah.
Yes.
Thank you so much.
I'm Andy. I'm one of the co-founders at Keywords AI. At Keywords AI, we're basically building a Datadog for LLM applications. We right now are targeting C to Series B startups for their evaluation and monitoring use cases. I'm going to jump right into how it works to integrate and some of the features our users love. Here is a fun thing we built for our users. It's our onboarding speedrun, inspired by the Olympics. So there's two ways to integrate our product. You can either send us a raw API call of your LLM payload, or you can use our proxy, which is basically using the OpenAI format to call over 200 models with the same code. So the proxy will just look like this. We integrate with Auto Framework. If you're using, for example, it just looks like Anthropic code, you switch the base URL to us and you create an API key on the platform. To go into the platform, here is something you'll see if you've successfully integrated with us. So you get to see all your important LLM metrics, things like how fast your system is. So if you're building voice AI, obviously latency is important. So you might want to look at P90 for TTFT. And you can see for this month, we are seeing faster response time compared to last month. We also have things like top models. If you're using multiple models, you can also track users by passing user identifiers along with your LLM calls. You can also track some of the eval features we have here to see if your LLM system is hallucinating or doing a good job.
How do you know if the LLM is hallucinating?
Yeah, we'll get into that. Before we talk about evaluations, let's first talk about our logs feature, which is the most used feature on our product. So on the side panel here, you can see every single relevant metadata about your LLM request. So things like who's sending in this LLM request. You can also pass in any additional key value pairs as custom properties. You can see where your deployments are. You can see all the metrics, like how much each log is costing you. You can add in user feedbacks, notes, and the logs will be right here. Everything that goes into an LLM and out of the LLM we log. Going into the evaluations, some of our users would set a random sampling of the logs to run evaluations on. They do this because if you run it on 100% of requests, this will be very expensive. So right now, we only support using LLM as a judge to run evaluations, where you can either use our pre-built evaluations, thanks to our friends at Relari, which is an open source evaluation framework, or you can build your own custom evaluations by just giving it a definition, a scoring rubric, a min and max score. So once you set this up, 5 to 15 percentage is a number I generally would recommend for. You will be able to see these evaluations you selected run on that percentage of your logs. And you can also go to the important logs and run them manually. So you can see things like readability, sentiment, stuff like that. Any questions on this?
My question is jumping off what Tom said about the pain points that drive adoption. What is driving customers to actually get all the way through that onboarding speedrun and then integrate?
Yes, so that is one problem. I wouldn't say it's a problem. It's one thing we're always trying to optimize. I think in the past month, I've tried out at least 5 different onboarding workflows because it seems to people that this might be a really hard product to integrate, but in reality, some of our fastest integration is just literally a minute or two.
I will say that as somebody who makes developer tools, there is a bimodal distribution. Your best customers are often your quietest customers. They just set it up and it works and they never talk to you.
Yes.
And the customers that talk to you and talk to you and talk to you, a non-trivial percentage of those customers never pay you much money, which is a little bit counterintuitive.
Yeah, so what we do is if they're not able to integrate themselves, we are literally on call 24/7. I have my Apple Watch on me all the time. If you text me, call me, Slack me, I'm available. Our customers know that and they love us for that.
I love that. That's a good note to end on. We're trying to keep these demos short, but I really enjoyed that demo Would love to talk to you more about it, and I'm sure other people here would too. Thank you so much.
Yeah, thanks, guys.
All right, nice to meet you guys. I'm Vaibhav from Boundary, one of the co-founders here. We did something dumb. We made a programming language. So we'll talk about it, and we'll talk about how we make it a lot better for you to both write code with LLMs and then get better data out, and also write better evaluation loops. The first thing first, how many of you have used function calling for OpenAI? How many of you, just to give you a quick context of what it is, function calling allows you to go from this markdown output to this, which is a lot more structured and a lot more relevant. And as you can see, I can actually highlight links, I can have things come out, I can know why you should hire me, probably don't, but you can see that out here. But what gets really interesting when you use something like BAML is when I say something like, actually, screw
BAML is Boundary ML.
BAML is a programming language. It stands for basically a made-up language. Our logo is a lamb, where it's really called BAML. Screw a resume, tell me a chess move. So if you don't use something like this, is what happens. You will get a chess move. So if you're ever writing a chatbot or doing anything with LLMs, your users will basically be able to do some sort of prompt injection and screw you. If you structure data, nothing comes out. It works out perfectly, and you can actually see the name is unknown. So let's actually dive into this really fast and see what the code looks like, because code is truth. One of the first things that we like to say is we want to be in your code base.
Can you increase the...
Oh yes, I forget. I like font that is for ants. But let's just start with the concept of resume. If I wanted to write a function where I can extract a resume, let's comment all this stuff out so we don't do anything fancy yet. The way that this works in BAML is you just write a function, it takes in a string or an image as an input, and it spits out a resume type. A resume type is described right here in code, where it actually has skills, experiences, and experiences some other things in here. The nice thing is you can actually see the full prompt. So not only can you actually see the prompt before you render it, but you can actually see the full prompt. This includes any audio files, images that you inject into the prompt. If I suddenly do some sort of for loop or something in here, for x and 0, 1, 2, there you go. You can actually see it render out exactly. And the problem with LLMs is if you don't actually see the prompt, you fundamentally can't control what you're doing because the only input to the model is the prompt. Nice part is this works with any model. So you'll notice that you can actually see not just the prompt, but the actual raw request. Please don't record my API keys. But like in the case of Anthropic, you can actually see that we convert this image that exists, that's coming in from the resume, into a base64, because Anthropic doesn't accept URLs. But in the case of, let's say I only have Anthropic clients over here. I'll show that later. But let's talk about what BAML actually does for you. What BAML does is BAML guarantees that no matter what the LLM outputs, we will always output this resume data type. Let's take a look at this and just run a quick test case. So again, you can run your test right in here. When your test loop is really fast, what that means is your quality of your models is faster because you're just writing more tests. If you don't write tests, you can't have good systems. If you're not running your tests, you can't build better systems. So as you go write these systems, you can see over here, the model messed up. It put some backticks. We stripped it out and gave you the actual data type. If you do something more interesting like chain of thought, where you actually force the model to list out some facts before you're running the model, once again, you'll find that the model spits out facts, and we're streaming out the actual resume once it's actually ready and starts spitting out actual JSON at the bottom. We just find the right thing out of the model for you. It's an alternative function calling, and we do it way better, way faster, and we do it in every single model without you having to go do it. How do you write tests for this? The same way you write tests for any other thing in code. Now what I can do is I can say, for this function, for this resume, my input name must be Vaibhav Gupta. I don't have to use an LLM as a judge. I can just use the best way to write code, which is write code-based tests. And then the nice thing about BAML is it integrates perfectly with any language. So if I actually go ahead and import, how am I doing on time?
Got a couple more minutes.
Okay. If I actually want to go ahead and use that extract resume function that I have over here, oh, that's a different one. Like extract resume, all I do in my Python code is the following. I'll comment this all out so I can, from BAML, I'll make this bigger so we can go back to big font. From BAML client, import B, and now this becomes completely auto-completed, and my resume type is always going to have all the fields that I had in my actual code. So if you can see over here, experience exists, and experience is always going to be a list of experiences. On the other hand, if I go ahead and just change experience to be a list of strings, my BAML code stays perfectly in sync with my Python code, and it'll always be in sync. You get static analysis on all your systems. You don't have to think about it. If you decide to stream, it works like this. Right? Yeah, also Copilot works with it, so that's nice. So let's pass this in for a chunk in stream. Let's go to this chunk dot experience. Now experience will automatically become a list of optional strings. You don't have to think about it. We do type safety guarantees for you automatically. And that's how what you saw in the example that I was doing over here, no matter what I do, it'll always output the right types. Basically what we do is we allow you to convert LLM functions into abstract type safe functions that you can use that will always guarantee what you're spitting out.
How much of an adjustment is it to learn to use YAML?
I think the best example is just seeing it. We have a thing like V0 where you can go ahead and give it any data you want. And guess what? We can actually have Claude auto-generate this schema for you.
Nice.
And it auto-generates them. Because we own the compiler, we can go fix the schema for you automatically, like V0 does for React code. And check it out. We're going to turn this into this. And you don't have to do anything. And under the hood, it's just JSON.
Pretty cool.
What do you do now? You take this code, you add it to your code base, copy and paste, and you just bring it into like your schema format right here. And now we have a test case that I can play around with in my code base with a full prompt. If I want to tweak it, I can go do whatever I want, and it just works.
Last question, what's the state of the art out there alternative to this? Is it like the OpenAI guaranteed?
Yeah, so OpenAI released structured outputs. We crush them. We actually, and the reason we crush them is, I'll give you like a quick intuition about this, if that's interesting. Why do we beat them? Background's algorithm design, so I helped build Face ID for Google. Think about Face ID is not a model. Face ID is actually a model plus like 7 different algorithms that make it actually work, because algorithms plus AI is the best thing you can do. So what we do is we take the output that a model gives, and then we apply a bunch of algorithms. So let me just, I think the easiest way to show this, don't use quotes around keys. So, I have to zoom out, sorry. When I actually go run this test case, you'll notice that the LLM will output results. Sorry, LLMs are slow. This is the worst of my demos. But anyway, while this is happening, or actually we have a bug, you'll notice that the LLM in this pipeline actually messed up in JSON. It did this JSON, didn't output keys, there's no quotes anywhere in the whole thing. It's still parsed correctly. The reason that we do that is because we have an algorithm that's called schema line parsing that is able to find an approximately correct, the approximate result from an LLM, and then fix that. And we do that in under 1 or 2 milliseconds. So if this is interesting, give it a shout. It's completely open source. Completely free. Huh? Oh yeah, if you look up BAML on GitHub, #1 result is Bank of America Merrill Lynch. We're #2.
Awesome, thanks.
Thanks, everyone.
All right, we got Laminar next.
Now I'm realizing that what we're building is the amalgamation of all the previous companies who demonstrated today, the view, the keywords, and even the BAML, because we have BAML on the platform, actually.
Oh yeah, go Laminar.
Yeah. And what we're building essentially is the observability, but with a sprinkle of analytics, right?
Can you, before you demo, can you just say a little bit about what you were building before? Because you demoed before,
Yeah,
it's
yeah.
different.
Yeah.
And I think that what you went through was like a clarification and a slight pivot through talking to a lot of customers.
Yeah, sure.
Yeah, what did you learn? What did you switch to and why?
Yeah, essentially we built building before that something similar to this actually, but the main entry point to that was our pipeline builder, right? I guess previously our main selling point was the orchestration engine that we built, and we thought that it's the greatest way to build an LLM application. It's not the greatest, it's a good way to build an application, but it's really sometimes goes in your way, right? We talked to a bunch of people about it. Product managers really like that. Product managers were really excited about it.
Product managers were excited.
Yeah, product managers were excited about it. The developers didn't really care about it. Developers want to write synchronous code, as Bama guy said. They want to write synchronous code. Am I speaking too fast? Can you understand me? Yeah. Developers, they want to write things in code. And that's why this idea, and the number one problem was that this was the main entry point into our platform, right? You wouldn't get the observability, you wouldn't get evaluations that we have without building your entire application as a graph, right? I don't know why we pushed for it for such a long time. I guess we are also like obsessed software engineers because we built really, I wouldn't call state-of-the-art, but it was an extremely great engine which executes these graphs. So we are obsessed with this. We really pushed it and demoed it actually, I think 5 weeks ago or more than that. But then we hit the wall when we I realized nobody actually wants to buy that except for product managers.
Terrible audience.
We actually talked with PG, and we're actually doing YC right
Paul
now.
Graham.
Yeah, we talked with Paul Graham about it. We talked with our group partners about it, and then I said, actually, we just have to cut this entry point and just make it accessible to everybody. If you want to do evaluations, you just go ahead and do evaluations. If you want to do observability and tracing, you can just go ahead and just add this one line of code, and it will automatically instrument your code similar to the Weave guys actually. Yeah.
Awesome. Yeah, show us.
Yeah. So it's the observability is actually literally the same as the Weave guys, right? We do one-line code auto instrumentation behind the scenes, right? We have like full tracing, right? It's not LM proxy. It's literally tracing of your entire application. Similar with decorators, but we have really nice waterfall UI, similar to Datadog. We trace everything, we trace attributes, prompts. The one caveat at the end, our unique insight on top of everything is that, as the Canonical guys said, that they position themselves as a mixed panel for voice agents, right? We position ourselves as a post hoc for LLM applications. And now the main point that the guys from Canonical mentioned is that once you go into production, right, number of traces that are coming in the order of thousands. And you're literally unable to go and look at them manually through all the traces, but you still want to get the insights from them, right? For instance, what is the user behavior? What's the most common question? Or did my agent hallucinate it, right? And you cannot really catch these kind of events programmatically because the output of the LLMs is pure rich text, right? You can't really catch whether my agent or whatever answers the question based on the content that is retrieved, for instance, right? But the things who can do that actually are another LLMs, right? And what we did essentially, we built this just an infrastructure, and you can call it like online evaluations, which we let you design as the pipelines as an LLM pipelines with the prompts and so on, and actually with the BAML JSON schema. We really love BAML, yeah, we should use this. But yeah.
So if I recap, you're using the DAG builder to create evaluations, evaluation
pipelines. Yes, yeah. And we run these evaluation pipelines on each request or whatever you want to run it in the code, because you trigger these events from the code. And once you trigger this event, we register this as an event essentially in here. And your, let's say like 1,000 of traces just reduced down to in this case I can just filter it down by something like, I'll type fast. Yeah, so now like your 1,000 of traces are reduced down to 7 traces, and now you can actually go ahead and inspect everything, and you can see all the statistics of what is the most common event, how many times my bot answered correctly or not, and so on. So essentially going beyond that, not beyond just looking at the traces and looking at them themselves, we actually mine statistics. So essentially we are applying the product analytics approach to the LLM agents.
So this is quite a twist. You started with Visual Workflow Builder that also had observability along with it, and instead you completely twisted around the product to lead with observability, and the Workflow Builder helps you develop evals.
Yeah. But the Workflow Builder also doubles down as just general pipeline chain manager, right? You can use it as an API. You can build stuff like this. It's still a great Workflow Builder, and it's like one of our advantages. And another really key advantage over Weave, right, is that we are fully open source. Right? Yeah, we're fully open source. We are extremely fast. We're written on Rust. We have extremely scalable and highly available infrastructure. We have queues. We have RabbitMQ. Our analytics is on ClickHouse. It's state of the art, and it's literally sitting right here. I can go ahead and look at our backend code right now, and you can even look at how we integrated BAML, because what we did. We really like BAML actually. We are huge fans. We went to their library, we stripped away all the code, we left only the parsers, so integrated it directly into our library. Yeah, and we're huge fans. It works extremely well. You should definitely use BAML in your application. We're huge fans. Yeah, or you can use the BAML in our platform also. Yeah.
Awesome. Thank you.
Yeah.
Thanks. So you haven't launched yet.
Yeah, we are in private beta. We are launching next month at TechCrunch.
All right.
Yeah.
And launching on Product Hunt when?
Sometimes around that.
Okay.
Yeah.
Why haven't you launched yet?
So we have been busy building, and we are running a private beta right now, and we have like close to 500 people on the wait list. So we have been like one by one with each users, like we are doing the right things.
Awesome. What do you got?
This journey with Lamatic started almost a year ago when I moved to US first of all, and we started building this app called as Dinnerfy, which was really like an AI thin wrapper, like Spotify for dinner. And we actually launched, we built the whole product within 6 months, and we launched on production. We got product of the day, about 10,000 users in the first week. So that was an awesome launch. And to summarize, like how we actually typically develop applications is basically you have to iterate over prompts, figure out what are different prompts that you have to work with, integrate your own custom data using RAG or other memory agents. You have to evaluate different models, try to negotiate the credit cost or get model credits or something, deploy API. Then you have to like operate this, develop apps, you have to give documentation to your front-end developers, keep updating your Swagger API, post it on Docker and whatever. And we did all this, and then we realized, no, this is not the way future of Gen AI application development should be, right? What if there was a way to abstract all that complexity into a single layer that is performant, reliable, and scalable? So that's why we built Lamatic, a platform that helps you build Gen AI apps in minutes with a managed visual workflow. I know a lot of people have this for visual workflows, but there is quite alternative in Lamatic to use both visual workflows and declarative YAML-like configuration. So whichever you prefer, or you can bring your own code as well. And we provide like a very fully managed and optimized layer of VectorDB, integrating different apps, data sources, and deploy all the workflows as a GraphQL API. So it's federated and you don't need to worry about documentation, and deploy it on the edge. So if you're running multiple LLM prompts and each prompt is adding at least like 200 milliseconds of latency, and you are running like 20 prompt chains, that means you are adding 2000 milliseconds latency. So by deploying each workflow to edge, we reduce that latency. We help you deploy a really fast application. Yep.
Who are you building this for?
It's for any company who wants to build reliable Gen AI applications, basically like early stage or seed stage startups.
Who are you best for? What kinds of applications are you best for?
Building Gen AI applications, full stack applications, or typically companies who are just like getting into the venture of Gen AI development, prototyping really fast, so like Supabase or Firebase for Gen AI, that type of level. So what I'll do here is that I'll show you like a quick sort of walkthrough and demo of what Lamatic is and how you can build applications. So Lamatic gives this 10,000 feet view of all the data sources, different models that you have connected, and all the apps that you have connected. But at the core of Lamatic, we have these workflows. And workflows is like a visual, again, concept of using like very easy to configure prompt workflows that you want. And what I've done for this demo is that I've tried to create like a demo pitch generator. So you can see that if I want to build an application, I can simply create my GraphQL API over here. You don't need to worry about the JSON schema if you are trying to define the input parameter. But if you want, you can also customize your input JSON schema over here as well. And then passing the information to all these variables is also very easy. You can easily pipe the variables from one point to another. So it's really easy and fun to actually use Lamatic and build applications. And like to test any of this workflow, you can easily go and over here. So let's say Laminar open source. So this is basically testing the prompt, and it will like just send the result right over here. But where the true magic lies with Lamatic is once you are ready with your application, you can simply hit the deploy button. And what we really do is that we are deploying this workflow on the edge, and you have all your deployments which you can easily roll back and switch back and forth from. And then we create like automated API that you can just pass on to your developers, and they can easily integrate with Node.js, Python, or Curl. What also is fun is that you can basically try the edge directly over here as well. And you will see like the prompt will run significantly faster as compared to how it runs on the edge. If you are curious about the metrics, you can also drill down into the execution logs and see the traces of each activity and what was the output. And we also integrate with third-party LLM observability tools like LangFuse and PostHawk, so you can stream your data to those platforms as well.
What's the number one thing that is keeping you from launching?
We actually are in launch phase. We are just like doing like private onboarding for all the customers.
What's the number one thing that you're working on there?
It's basically like making sure that the platform has all the capabilities that user needs, like focusing on the sort of reliability and credibility of the product.
So for workflow builders like this, there's always this tension between how many guardrails you put up so like the result is predictable and like how powerful it is. That you can constrain it too much and then you have to focus on some very specific applications, or you can really open it up and then it could take a long time to learn and what you do can be unreliable. Like how have you navigated that? Have you picked a spot in that spectrum or?
Yeah, that's actually a good question, and that's one reason what we have been trying to figure out, like what's exactly are the right team that this product is right for. So as I said, like when I was building, like I have built a product that I would want to have when I was launching this product a year ago. So it's basically for the 0 to 1 builders, and then once you are ready, you know that this is the product that you want to go ahead with, then maybe you can pull the code out from here, deploy it on your own infrastructure, or go from there on production.
Do you have plans to keep them after they've gone from 0 to 1?
Yeah, what I think is like in the future there would be more like edge LLM cases, like how mobile LLM is becoming a thing as well. There would be more offline LLMs on people's devices. So what Lemmatic wants to be is that DevOps layer for you to build your workflows or deploy your code to use these devices or edge easily through our platform.
Awesome. Do you want to do like a little audience feedback since you're launching soon? Okay. So can you, everybody in the audience, just forget everything you heard. Just pretend like you didn't hear any of that. Can you describe what you do in one line?
With Lemmatic, you can build GenAI applications in minutes and deploy it as a GraphQL API over Edge.
Okay, show of hands, how many people in the room feel like they understand what this product is and why it's special? How many of you, keep your hands up if you're interested in using it. Okay, so can you repeat back what you think is the core? What do you think this product is?
I like building in minutes, so that's why I would use it for. Yeah, like building the whole stack is like always the same for every product that you build. So that's definitely useful. Let understand the graph.
How many people are aware of another tool that does this? A few? Yeah, I guess my vague sense is that there are a bunch of tools that are doing this, and I was trying to understand like what is the unique insight or where you're focusing where other people aren't focusing.
Yeah, it's basically trying to make sure that the back and forth between the backend team that is developing these GenAI applications and the front-end team that is trying to integrate this GenAI application, that reduces a lot. So where backend team or the product managers can easily iterate over prompts, they can push the applications to development, and then the front engineers don't need to like go through the docs or the Swagger API. They can easily just auto deploy this application.
Awesome. Let's end there.
Yeah.